Dear students, let's study activity series of matters. Activity series of matters plays a very important role in study of chemistry, especially inorganic chemistry. In the activity series of matters, matters are arranged from top to bottom, we can say in decreasing series of activity, and from bottom to top in increasing order of their activity. It means the bottommost matters are the least reactive one and topmost are the most reactive one. And what is the criteria of activity of matters? That is the tendency of donating electron and turning into positive ion. The ease with which a matter donates electron, like potassium, with great ease donate electron to become potassium ion. But aluminium ion will do so comparatively with great difficulty in comparison to potassium to form aluminium ion. That's why potassium is at the top and aluminium is having so many steps below the potassium. Sodium is just a little less active than potassium. Calcium is even less active than sodium. Magnesium is even less active than calcium, and so on. This is how the matters are arranged in the activity series of matters. At a place there is hydrogen as well, despite not being a matter. This is because that though hydrogen is a non-matter, but even hydrogen has a similar tendency to donate electron. Hydrogen donates one electron and turns to positive ion, just like sodium donates one electron and turns to sodium ion. Due to the similar tendency, hydrogen is also placed in the activity series of matters and in the same order. It is less active than lead but is more active than copper. That's why it has got a place between lead and copper in activity series of matters. Mercury is even less active than copper, silver is even less active than mercury, platinum is less active than silver, and gold is even less active than platinum. So why they have got this position in activity series of matters. Children, by using this series we can study the different compounds like oxides, hydroxide, nitrates, etc. of these metals. We can compare which metal will displace another metal from its salt solution. We can also check and compare the ease with which they react with different reactants like oxygen, water and acid. For example, potassium, sodium and calcium being at the top react with oxygen at very low temperature. Sodium and potassium are so active that if we just leave at any temperature open in the oxygen, they will react with them to form their corresponding oxides. Calcium needs a bit of the heating, whereas magnesium, aluminium, zinc, iron, etc. are comparatively less active, so they need to be heated to form their oxide. Though aluminium sometimes at even normal temperature can form a little bit of the oxides with oxygen of the air. Same goes about water. Potassium, sodium, calcium react with cold water to displace hydrogen and form their corresponding oxide or hydroxide. Whereas magnesium, aluminium, zinc, iron are comparatively less reactive, and magnesium somehow react with boiling water, but other will react only with steam to displace hydrogen from water. Same goes about acids. The top metals react with very dilute acid to displace hydrogen and form salts. Other metals will not react with so much of the ease. If we come down for another metals like lead, copper, mercury, etc., they will hardly ever react with water, means they will not react with water to displace hydrogen. So comparative study of different matters with not only oxygen, water and acid, but with other substances, and to study their compound, activity series of matters is very important and helpful as well. On the basis of this, we can decide whether displacement reaction will take place or not. For example, see, iron is much above than copper in the activity series of matter. So if we write FeSO4 plus CO, then this reaction will not take place because copper is less active. It will not displace iron from iron sulfate. But if we take iron and if we place in copper sulfate solution, then suppose this is copper sulfate solution and we have put a iron knife or any iron article or maybe iron nail into it, then after some time the blue color of the solution will gradually turn green because this reaction will take place. Iron will displace copper and will form ferrous sulfate, which is green in color, whereas copper sulfate is blue in color, and the copper will get displaced, and this displaced copper will get deposited over the iron article, nail or knife or whatever, so that the iron article after some time will look of the copper color because of the copper coating over it. Similarly, in comparison to silver, copper is more active, so copper can displace silver from silver nitrate to form and silver will get displaced. Suppose we are taking silver nitrate solution over here, and if we place a copper wire or copper spring into it and leave it for some time, then if we take the copper spring out, then we will see now it is not of copper color but it is coated of, it looks like silver because the displaced silver will get deposited over the iron copper article or the copper string. So in this way, with the help of activity series of matters, not only we can study displacement reaction, but also we can compare and study many reactions and compounds of matters. That's all.